Okay, welcome to this programmer seminar on Imaris XT. My name is Marius. I just like to make the introduction here and then pass the word to Igor Beati, one of our senior engineers, who will guide you through the programmer details of the software. As a background information, we started the development of Imaris XT because we saw that more and more biological laboratories started an in-depth collaboration with computer scientists to specifically implement image analysis for their research topic. And at that time, Imaris was a closed application, and so many labs who liked the features of Imaris could not really work with it because it was not open enough for them to extend the functionality and really implement the tools they need. And that was the starting point for Imaris XT. Now, without much further ado, I would like to pass the word and the microphone to Igor, who will then lead you through this seminar. I will see the chat. And if you have any question during the seminar, please feel free to post your questions and comments into the chat box. I will pick it up from there, answer the things I can answer, or just interrupt Igor to focus on a specific topic if needed. Okay, let me just transfer now Igor, the word is yours.
Hello everybody. I share the desktop. Now, can you see my MATLAB window? Okay, fine. Let's start. So today I show you how to use to access the DataSet using the COM interface and the spots interface. So first start launching an instance of our application. So we store in a variable Imaris, and we use X server, and we want to specify that we start an instance of the Imaris application. So this way, active server is a function of MATLAB that calls the interface and launch an installed version of Imaris. Now you can see in the task manager we have a process Imaris, but we don't see it. We must make it visible. So if you press the tab in MATLAB, you can see the possible function. It's a sort of autocompletion. So we make it visible and visible. Oops. Visible equal to true, and Imaris will appear here. Now we have used one of the methods of the COM interface. We can look at all function we have here. So we can see in the class hierarchy the Imaris application interface, and we have all of these methods, and we have used here the visible button. Now we can load and use Imaris as if we had it started normally, and we can load one dataset. Now we want to implement a function that inverts one of the slices of the dataset that is loaded. So first we have to access the image intensity. Here we look in the interface and we see that we can access the dataset of Imaris using this method and dataset. So we use all variable, Imaris, and then pressing the tab button on the keyboard, we have all possibilities. Then we use the DataSet one here. Now we can store this value in another variable, and the dataset equal to the dataset. Now we want to access the intensity once we have a reference of the data. In the interface, we see in the dataset we have one function that is getDataSlice. Here we have the 3 parameters as input and 1 as output. So we have to specify what the index of the slice, the index of the channel, and the index in the time. And then we have a return value, all the intensity of the specified slice. So we want to store the image intensity in the slice function, in the slice variable, and we call the dataset get DataSlice. Now we specify the index in the Z dimension, and we have 64 slices, so we have an odd number of slices, so we have 2 middle slices, the 31 and 32, the 32 and the 36, sorry. And for example, get the 33 one. Now be careful because the first index here is starting from 0. So the 33 slice here corresponds to the input 32 here. The same for the channel and time points. The first are the number 0. So don't show the output because it's too big, but we can show it using a method function, image show, and show the slice. Now, you see, another thing you have to take care is that the first dimension in MATLAB is the vertical one, the y dimension is the first. So we have to transpose our values to get the same result as displayed in Imaris. So here it is. Now we have the values, we want to invert them. So we subtract our values from the maximum of all values. So we get our maximum value is the maximum of all values. Using this notation, we convert the 3-dimensional array to a 1-dimensional one, and because the maximum function returns the maximum of each column. So in this way we have only one column, and we will have only one value. Here we can do the same, taking the maximum of each column. That is the same. So the two are equivalent. But this one is maybe faster, so we get use this. And now, so to have the inverted values, we subtract from the maximum our intensities. Now we can show them using as before invert. You see where we had the maximum values, now we are the minimum. We can compare them using another MATLAB function, What we want to say, we have two plots, one showing our slice and the other one showing the second inverted one. Now we can compare them and see, okay, it looks good. Now we want to set back this inverted value in our dataset. So we can look again at the interface and search the right function. We have here SetDataSlice. We have the same parameters as before, but this time the intensity data has to be provided and not a return value. And we can use the same arguments for the indices. So we can get this one, use the SetDataSlice in the get one, and provide the intensity value. Slice inverted here, this way. So you can see in the surpass window we have this value. So there are two ways how to do this. We can have you can transpose every time you get the values and work, and then transpose again before you set them, or you can keep it consistent, never inverting it. The same goes for the indices. When you get the indices, you can always add one before working in Matlab, and then subtract one, or always know that you have one less when you want to set them. Personally, I prefer not to change them, but you can do what you prefer. Just be sure you don't add one to the intensity or to the coordinates, because these are common errors. Now we want to build a function that do the same thing we did now. So we can create a new function called Invert middle slice, who gets as argument our Imaris variable. And use the window, we can simply copy this to the window. And now here we don't want to show the output. We don't need these values. We don't need this. And so we have our invert function. Save it. And now we can call invert middle slice with Imaris. And so if we do it 2 times, we annihilate our first call. Now, of course, the 32 is not always the first index, it's always the middle slice. We have to compute it dynamically. And how can we compute it? We look again at the interface, and we see that our size is defined by this, the value of this variable, and the middle slice is 1/2 of this value. Is equal to DataSet. Here we don't have autocompletion because tab. Oh, here we have it. Nice. But normally you don't have, when you don't have this the value of this variable stored in the workspace. So you can always go here, then use the autocompletion, copy and paste again in your editor. And now we divide by 2 to get the middle slice. So this is one variable of type integer, so even if it's an odd number, dividing it by 2, it will be automatically rounded. And MATLAB, for default, round by excess. So if you have 9 slices, you will get 5. And not 4 or 4.5. So now try to use it again. So it was made before. Okay, it works. Now we want to have this function here as the other extensions, and to do this we must add. So if we start another Imaris and we don't launch MATLAB, we cannot access this function. Look here, we can't do it again. To do this, we have to go in the extensions folder where we have our Imaris application and write a function here. Luckily, we already have our code in the right place. With a while making plus. And here we need to add an adder to our function. Now look at it. So here is a commenter completely ignored by MATLAB, but it's used by Imaris. At start, you look through this code and uses this XML code. So here we say that we want to add in the menu of the Imaris, we want an object, a menu entry called InvertSlice with a MATLAB icon, and when we select this menu, we want to start the invert middle, call the invert middle slice function. So this is the header, and then this is, as before, we just changed the name of the argument, and here is the path as before, so that we can call from the command prompt, we can call the invert middle slice of our Imaris instance that now we no longer have. And then this second path is used when you call the menu entry. So this way we can load a retina, having the image processing this invert middle slice function. It starts an Imaris MATLAB runtime, and then it executes the function. This way. So this code you can find similar into every extension installed with Imaris, so you can easily copy paste it and then change the strings here and the name of the function. All the rest should be the same. Now here it is. I think it's all. for the Imaris dataset. So we have seen how to access the data, modify it, and set them back, and how to build an extension from that. So you have to see here you can even close MATLAB and InvertSlice will work. Now we can go restart MATLAB.
Just one second.
Yeah.
Thank you, Igor, for the start. I just wanted to tell everyone, if you have any questions or if there is things that run too quickly, just let me know by typing into the chat box. It's really, this seminar is really for you, and so if you think we are going too fast, let me know. Otherwise, I just step out of the way and let Igor continue. Thank you.
Thank you, Marius. So now start Imaris again, and of course make it visible. Here it is. We use another data set. Here we have a time data set. Now we can create a new object. As we do here, we add spots. We can do it using the COM interface. Now we do the same. So we want to say in our variable we have Imaris, and then to generate a new object, we see in the interface, we go back to our namespace, our class hierarchy. We see in the Imaris application we can have a factory that is used to create objects. Now we can create spots simply. Now use the factory of Imaris and create spots. Create spots. Now we have some spots, but they are flying on the air and we don't see them. Now how we add them here? We have another object we can get from the Imaris instance. Imaris. We have the surface scene. We can see in the COM interface. The surface scene is another object, one container where we can add some child, some other objects. So we use this add child, and we give as argument add child. We give as argument our spots. Now we shall see them. Here they are. Okay. Now we can, so they are here, but they are empty. So we have no value, no data to display. We have no values here. How we set values? We look at the interface of the spots. We have spots. We have one function here, set. We can set the position, the time indices, and the size of the spots. The position is a n by 3 array of float values where we specify the coordinates. Every line of the matrix has 3 entry, the x coordinate, the y, and the z for each spot. We have to provide a vector of n values with the indices in time, and then another vector with the radius of each spot. So first we can set the position x, y, z. We can set the position 10 on x, 10 on y, and 0 on z. Then the second line, we specify the values for the second spot. We can have the same x value, but have it above, and then the same z coordinates. Then we need to specify the time points. We have to provide 2 time points, 2 times the first time point, and the first is 0. And the radii, we can have one of size 10 and the other 20, for example. And then finally call the set method of our spots. We set x, y, z, the times, and the radii. Now we should look them. Okay, the one above is below because we have origin top left. So here we have the expected coordinates. Another function we have in the com interface. Here we see that the spots are some kind of data item. So we have all mass of the data item. We have even for spots, for example, the set color method. Let's try to use it. We can set color. It's an RGB value, so we set R to the red color at the maximum, the G at the minimum, and the blue at the maximum. And we set no transparency, so we have purple spots. Now, manually doing it is not really the target of the com interface, so we can create some more spots. For example, we can have 20 spots. Now we auto-generate the coordinates, the radii, and the time points for 20 spots. So we want to, for example, draw a semicircle. So we want to specify the angles we want. We can use a Matlab function called linespace, who can generate a list of values between two limits. So the minimum we want is 0, and then let's say in radians we specify 3/4 of a circle, and we want 20 values. Look them here, and it's all there. Now, if you know the formula of the circle, we have to use the cosine on the x dimension and the sine on the y. So we say the x coordinates are some value, some center value, and then we have to specify some radius to multiply our coordinates. and here we have the x value, and then for the y value we take the same, but using the sinus function. We can have a look at them using the plot of Matlab, x, y, and say we want points. Here you see our 3/4 of the circle. Now we can have constant c. We want to have it to n value, a vector of size, and all filled by zeros. This way. And now we want to have the time points are 0 themselves as well. And for the radii, we don't want to have to be 0, so we had some radius. For example, for here we have now 20 values of 20 values that are equal to 4. Another way to do this is to create a vector of 1 and multiply by 4 once and multiply by 4. So it's basically the same and the performance is the same, so choose the one you prefer. Now finally we can set our values, but we have first to generate here, not get, set, we want to generate this matrix. Now we have 3 column vectors, and we want to have x, y, z equal to the concatenation of x, y, and z. I did a fault, of course. We have the x and y are now horizontal instead of vertical. So first transpose them, make them on the vertical, and then concatenate them. Finally, we have the right thing. So look at the size of our variable. It should be 20 times 3. Okay, it's right. And now we can set the value and set x, y, z, the time points, and the radii. Okay, we have them. Now they are all on the first time point, so we can split them over different time points. We already have the coordinates and the radii are okay as they are, but we want to change the time points. So we can have now times will go from 0 always up to n minus 1. So we can have the same, if you are more confident, using 1 to n and then subtract 1, you can have the same result. Now set them again, and we should have one spot for each time point. Now we want to build a track from them. So we have to set track edges. We can see in the interface, we can set a list of pairs with the indices always here starting from 0 of the spots we want to concatenate. So this way we can use set track edges. Always use the tab to go faster and concatenate the first with the second. So this way we have here the track. Maybe you don't see it well. You can have a cylinder with some bigger radius. Now you can attach the first with force. There is no problem. You can attach any pair of spots. There is no check in this sense in Imaris. Just not to specify here 30. Then it says, okay, the index is too high. Now we connect the first with the second with the third, the third with the fourth, and so on. Here we have all the first spot connected. Now we want to do it automatically. So if you look at this, you can easily that they are increasing 0, 1, 2, 1, 2, 3, and we can do it automatically using the first equal a list from 0 to n minus 2, and the second goes to 1 up to minus 1. This is the last one. From the second to the last one, from the first to the... Okay, now do this. We can declare our edges are equal what we did here. And on the second line, we add this. Here we have them on the horizontal, but here they are expected to be on the vertical. So simply transpose them. Here they are. Finally, we have the right edges, and we can set them, set the track edges, and we send them. So we can run our animation and set them. And so now that's for the tracks. Now another function very useful in the interface you can see is get selected indices. Get selected indices returns the sub-selection of the object. If you switch to the Edit tab or the Statistics or the Filter tab, you can here go to Select and select one spot. If you go to Mouse Select Spots, you select one of them, and you can see get this index. So let's get the selected indices. We get the index of the fourth spots. Here is 5 because always there is the gap of 1. Here is starting from 0. This get selected index. So for example, we can have our radii. We want to set the radii of the selected spot to make it a bit larger. So the radii of the get selected index, we want to have it equal to 15, but always be careful here. Now we need a MATLAB index, so we have to increase our Imaris index by 1 and make it so. And then again, we have to set our values. This way, the all variable still contain the right values, so we can use this method. And we have this one spot much bigger. The set function remove the track, so we can set them back. So we can even have a multiple selection using the control of the keyboard. Holding the control on the keyboard, we can select more spots. For example, all of this. Do the same here. Get selected indices to 15 and set the values and reset the edges, and we will have multiple spots increased. Okay, here we are with the spots. Now we want to build an extension who works with the spots. So create a new function as we did with the dataset. We need an header for this function. Here it's already prepared. Now instead to have it as before in the menu, we want to have it in the Surpass tab. For the Surpass component spots, we want to have it called connect spots, and it shall call the function connect spots. Now shortly implement it, so we get the spots are equal to the Imaris Surpass selection. Now we get the sub-selection of these spots is equal to the spots. Here always copy paste so that we don't make it wrong. And now connect the spots, so we have to get the old edges, spots get the track edges, we save them, we add a new edge concatenating them with our selection. But here we see they must be 2, so add one test. So if the size of our selection is different from 2, just show some error message box. Please select show spots and simply do nothing, return. But if we have 2 of them, here we have in the edges we have spots indices exactly like the selected indices. So they are perfectly compatible, and we can have them this way, and then we just have to set them back. This way, we save always in the extensions folder. Save it, and now we can close all because it should already be in the Surplus tab. So here we can the text spots and make them on a small window so they go faster. Here. Okay. Now we see here the connect spots function. Try to connect them, and it's say please select your spots. Okay, we don't have selected two of them. Let's connect this with this one. You're holding the control on the keyboard. You can select multiple of them, and now connect them, and they are connected. So if you don't see it this way, let's connect two other. Connect this one with this one. Connect them, and here they are. Okay. So I prefer to work here in MATLAB because switch to the right folder, because here if you do some changes, for example effect of implementation, and you launch it again here, it works because this is not updated. You have to close the command window, and then when you do it again, it will be reloaded, and you say, here we have a defect of implementation. And so you have every time to close this window and wait to start in MATLAB. Using this way, you can connect spots, but you have to start Imaris here using the ActX server, and then you have a valid Imaris reference, and you can go here, do it again. So do it smaller, bit of 4, generate them. Now that we have a reference to the Imaris application, we can have these spots selected, set some of them, run the connect spots, Imaris, and say defect is not working, so we can correct it, save it, and we never have to wait the runtime to start. So for development, this is much better, and we go here in the code and this one so require more time. Okay, I think I'm ready. I maybe show you fast. So here we have seen the dataset, the spots, a few of the Imaris application, the factory, and two other important objects are the surfaces. The most important function are at the surface, where we set the verticals, the triangles, and the normals, and we can get one surface back using get triangles and get vertices and so on. And another important object is the filament. Here we have the radii as the spots, and we can set the position like the spots, the radii like the spots, and the edges like the tracks. This is very similar and easy to use. So now I think I'm finished. I give back the floor to Marius, and thank you all for the attention.
Thank you very much, Igor. Let's go back to the meeting center with Imaris XT. You can see that it is a very powerful interface, and you can combine by a nice combination of very powerful tools of Matlab with the superb graphical capabilities of Imaris. You can really generate research-grade code very quickly, and it's ideal for prototyping, but also just ideal also to use the code in a way that not only the programmer itself in the laboratory can use it, but also biologists who are supposed to use your algorithms can easily use it by incorporating the new functionality into the user interface of Imaris. This meeting now is finished. We will keep the chat open for more time. So if you think of other questions, if you have any questions regarding Imaris, not only XT, feel free to post your question, and Igor and I will try to provide the answer right now. Thanks very much for your time. Have a good day, and Shervaze, who is in Australia, have a nice evening, and thanks for giving us your time. It's much appreciated. Bye everyone, have a good day.